Hello, welcome back. The title here is called Solving Proportions. This is part 1. So I'm incredibly excited to teach you this because we get to learn what a proportion is. And also in the course of this, we're going to start to solve our first equations here. And so we're going to be learning some skills that are going to really follow you for years and years and years. And you're going to be learning a lot here that's very, very important. So first of all, what is a proportion? In the last lesson, we conquered the idea of a ratio. A ratio is when you have two numbers and they are compared to each other. Like 3 boys in a class, 6 girls in a class, the ratio is 3 to 6. You have two numbers, you compare them, and you write them as a fraction to compare them, right? A proportion is when we have two ratios that are set equal to each other. I'm going to say that again because it's important. A proportion is when two ratios are equal to each other. And you already know all about proportions, really. Like, let's say I had the three boys and the 6 girls, right? So that means 3 boys and 6 girls, but that's the same ratio as 1 boy to 2 girls. So 1 to 2 is the same as 3 to 6, because in both cases they're half as many boys as girls, basically. 3 boys, 6 girls is half the amount of boys. 1 boy, 2 girls is half the amount of boys compared to girls. So a proportion is when we take two ratios and set them equal to each other. So let's jump into this first problem. We just kind of verbally talked about it. Let's talk about what a proportion would look like. 1 as compared to 2 will be equal to some unknown number. We're going to call it x as compared to 6. Now, this is what a proportion looks like. Now, the first time you look at it, it might look scary. Please take that feeling and just shake it off because it's not going to be scary by the end of this lesson, all right? What you have is what I just said. You have a ratio. This is a ratio. It's a fraction. And then we have an equal sign, and we have another ratio. And there's an equal sign there. Now, a proportion is when we have two ratios that are equal to each other. In other words, they have the same relationship, right? The same relationship between the numbers. But in this case, we have a kink in here because we have the letter X in there. Now, when you see a letter in math, don't get worried about it. Don't get scared about it. It just means we don't know what that number is. And we're trying to find that number. So it's like a puzzle. You're trying to unwrap the puzzle in such a way to figure out what X is. And there is only one value of X. The thing X is called a variable because it's unknown until we know what it is, right? It can be made to change until we know what it is. But there's only one value of X that works to make this proportion the same. Now, we're going to solve this in the correct way in a second. But let's just go over here and rewrite it again. 1 is compared to 2, right? Equal to something over 6. Now, we just talked about this a second ago. If I go into a room and I know that there's 1 boy for every 2 girls, then how many boys would I need to have if I know that I have 6 girls? Another way of thinking about it is, if this is boys and this is girls, then there's always, in this ratio here, there's half as many boys as girls. There's 1 to 2. This is half as much as 2. So if this really is equal to, if these relationships are equal, that means that whatever goes on top must be half of what goes on the bottom, because this is half of this. And so then this unknown thing must be half of this. What is half of 6? Half of 6 is 3. And this is the example that we just talked about a second ago, is that if I know that there are 3 boys and 6 girls, or another way to think about it is 3 slices of pizza out of 6, right? That's the same thing as taking half the pizza. If you're at a pizza table and you take 3 pieces and there's only 6 pieces in the box and you take 3 of them, then you've taken half of the pizza, because the ratio 3 compared to 6 is the same ratio as 1 compared to 2. They mean the same thing. That's why there's an equal sign there. So for this example, it's very simple. We know the answer has to be 3 because, the bottom number has to be double of the top. The bottom number has to be double of the top. So we know that X must be equal to 3. But what we want to do is solve this in a way that allows us to conquer more complicated problems. So we have what we call an equation here. This equal sign means it's an equation. Equation means equals, right? So when you see an equal sign, it's always an equation. Don't let the word equation scare you. It's something that we'll conquer. It's a new skill, but it's not hard, right? What we want to do is find the value of X that makes this equal sign true. We already know it's 3, but we want to not guess. We want to show you the skills to find the value without knowing what the answer is ahead of time. Now, here is the most important secret I want you to know for equations. when you have an equation with an equal sign, of course it has to have an equal sign, then you can basically do whatever you want to both sides of the equation as long as you do it to both sides. I'm going to say that again. It's one of the most important things you'll ever learn. You can do whatever you want to that equation as long as you do it to both sides. In other words, I can add a number 1 to both sides if I want to. I can subtract the number 2 from both sides if I want to. I can multiply by both sides by 5 if I want to. I can divide both sides by 19 if I want to. I can multiply by 27 as long as I do it to the both sides, because what this equal sign really means, it's kind of like at the playground when you have the seesaw or the teeter-totter, right? If I have it perfectly balanced here and I multiply this side by 3, let's say this is a 3, right? I put a weight there, it's going to unbalance. The only way to keep it balanced, because this triangle basically means it was equal, the only way to keep it balanced is by adding a 3, 3 kilograms to the other side, or 3, whatever it is, pounds you're talking about. So if I multiply this side by 3, I must also multiply this side by 3 to keep it equal. If I divide this side by 3, I must divide this side by 3 to keep it equal. You see the pattern? If I add something to this side, I must add something to that side to keep it equal. If I subtract something from this side, I must subtract something to this side to keep it equal. And the reason you're trying to keep it equal is because there's an equal sign there. So you can't just unbalance the thing. You have to do it to both sides. That is going to be the secret to solving every equation you'll ever solve. So we have the equation, or the proportion, right? 1/2 is equal to x over 6. Now we can add, subtract, multiply, divide, whatever we want to both sides, but we have an x here and we have a 6 here. What we want to do is get x by itself. If we get x by itself, then we've solved the question. We have x divided by 6. How can we get rid of the 6? So we want to get rid of the 6 from this side. Now we can do what we want, but we're going to multiply this side over here by 6. Now, if we multiply by 6, we must also multiply this side by 6. By multiplying by the same thing, it keeps it balanced. The numbers here would be 6 in this case. I have to balance it by multiplying by 6. But we have a fraction here. X, of course, is a letter, but it's still a fraction. So when we actually do the multiplication, we're going to multiply it as 6 over 1 and 6 over 1. All right, so what are we actually going to have on the left? We can multiply fractions. You've done this before. 6 times 1 is 6, and 1 times 2 is 2. And then there's an equal sign. Now, what are you going to have over here? You're going to have x times 6, but you don't really know what x is, so just leave it as 6 times x over 6. I don't know what x is, so I can't actually multiply it yet, but that's okay. I leave x alone. I'm going to figure out what that is as I get to the end of the problem. Now, on the right-hand side, notice what we have, 6 on the top and 6 on the bottom. This is like a 6 divided by a 6. What is 6 divided by 6? It's 1. So I can basically strike through them because 6 divided by 6 gives me a 1, and a 1 becomes invisible and you don't see it anymore. So what you have on the right-hand side here is just x by itself, because the 6's, they really didn't disappear. They just divided away and they gave me a 1, which is invisible. On the left, I have 6 divided by 2 is 3. Now I have 3 equals x. You can flip that around to be x is equal to 3. And now we figured out that x must be 3. It's the only value that works to make this thing right. So we circle that x is equal to 3, and then we can rewrite our problem, and we can say that 1/2 is equal to something, was x over 6, and we have figured out that that value that works is 3. 3 is the value that works, so we're just going to put 3 right there. So the value of x is equal to 3. All right, now we're going to solve a lot of these, so if you look at this and you're like, I don't know if I totally understand what he's doing yet, don't worry about it. We are going to do so many of them, it's going to be quite easy for you to see the pattern and what to do. In this case, we knew that we had a 6 on the bottom. We have to kill it. We have to get rid of it because we want to get x by itself. Right? The only way to get, since 6 is divided over here, the only way to get rid of it is to do the opposite thing. When you want to undo something, you do the opposite. So we're dividing by 6. We must then, to kill it, we must multiply by 6. So we multiply by 6 and multiply by 6. We have to do it to both sides. The 6's ultimately cancel away by dividing away to give us 1. And so x is on the right by itself. That's what we want. And then 6 divided by 2 is 3. And so x is equal to 3. And we have solved the problem. All right, let's move along. Let's say that we're solving the following proportion. 1/2 is equal to w over 12. Couple of things. First of all, notice that we're using a different letter, W. I need you to get used to that. Sometimes we use X for the unknown. Sometimes we use Y. Sometimes we use A, B, C, Q, R, S, T, V. It doesn't matter. Any letter you want, I don't care. It's just an unknown. We don't know what W is. We want to figure it out. But what we're saying is that this is a proportion because the ratio 1 as compared to 2 is the same thing as the ratio of whatever W is compared to 12. We want to figure out what W is. So let's rewrite the problem. We have 1/2 is equal to W over 12. Now we're dividing by 12 on the right. We want to get W by itself. The only way to do that is to do the opposite. Since we're dividing by 12, we're going to multiply by 12. And then over here, we're going to multiply by 12. And since we have fractions, we're going to write it as 12 over 1 as we're multiplying by 12 because we have fractions and that's what we do with fractions. Now, on the right-hand side, we're going to have 12 times W. We multiply the tops. 12 times W, we multiply the bottoms, and we get a 12. On this side, 12 times 1 is 12, and 1 times 2 is 2. We're just multiplying fractions. That's all we're doing. Now on the right-hand side, now we have a 12 divided by 12, and that's why they cancel and disappear, because 12 divided by 12 is 1. So on the right-hand side, all that is left is W. That's what we want. And on the left-hand side, 12 divided by 2 is 6. Flip it around and write it as W is equal to 6. And that's the answer. W is equal to 6. So the answer to our proportion is 1/2 was equal to some number over 12. That's what we wanted to find, and we figured out that the only number that works here is 6. So I can kind of circle that if you want to. So 6, the number W, that's the one that works. Does it make sense? Notice in our proportion, this ratio was 1 to 2. That means the bottom number was 2 times larger than the top. So if the bottom number is 12, then the only number that works here must be 6, because 12 is 2 times larger than 6. Now you can look at these easy problems and kind of guess what the answer is. But as we get more and more into math, you will be unable to guess the answer. So you have to learn the methods I'm showing you. You have to. I know when you first learn it, you may be like, I don't want to do that. That looks hard. But you must. And it will be easier, I promise, as we do more and more problems. All right? Let's move along. And I think the best way to conquer this and to kind of get over it is just to do it. So let's move along. Let's say we have the ratio 1/4, and we're going to set that equal to the ratio h, whatever that is, over 28. So this forms a proportion. It's two ratios that are equivalent to one another. So we're saying 1 as compared to 4 is the same as h as compared to 28. What is h? So first, let's rewrite our proportion here. 1/4 equals h over 28. We want to have a goal of getting h by itself. We're dividing by 28, so the only way to undo it is to do the opposite, to multiply by 28. And if we do it to that side, we must do it to this side to keep it balanced. And we'll write it as over 1 and as over 1 there, because we're multiplying fractions. Now what do we have on the left? On the left, we have 28 times 1 on the top and 1 times 4 on the bottom. On the right, we have h times 28. We multiply the tops, which you can write as 28h. And on the bottom, 28 times 1 is 28. All right, now notice what happens here. The 28 cancels with the 28 because they divide away. 28 divided by 28 is 1. So the only thing really left on the right-hand side is h. And on the left-hand side, 28 divided by 4 is 7. So we can flip that around and put the variable on the left, h is equal to 7. This is the only number that works in our proportion. Now let's rewrite our proportion. Our proportion was 1/4 is equal to some number over 28. And we're saying that we have solved for the value of this number, and it has to be this. Does it make sense? What it's saying is the ratio 1 to 4 is the same as 7 to 28. In other words, one boy out of 4 girls, or compared to 4 girls, is the same as 7 boys to 28 girls. Does it make sense? Well, the bottom number is 4 times larger than the top. And here, the bottom number is 4 times larger than the top. 7 times 4 is 28. 1 times 4 is 4. 7 is the only number works because when you take and multiply by 4, you get the bottom. When you take and multiply 4, you get the bottom. So 7 is the only number that works. I know that this work looks very scary at first, but it opens up doors for you because we will be solving what we call equations. These are equations. We will be solving them basically forever. You never stop solving them. Even when you get into college and beyond, you never stop solving them. So let's go on to the next one and we'll continue building your skills. And after a while, you will see the pattern in what we're doing here, even if in the beginning, maybe you're not totally sure. So let's write down our proportion. It's 2 as compared to 3, or 2 compared to 3 is the same ratio as the ratio y compared to 9. So when they're equal like this, we call it a proportion. So we want to solve for what y is. This might be one where it's a little tough to figure out what the answer actually is, right? So let's go ahead and take it one step at a time. Let's rewrite 2/3 is equal to y over 9. Now we want to get y by itself, but we're dividing by 9. So to get rid of it, we have to do the opposite, multiply by 9. And if we do it there, we must also multiply this side by 9. And since we're multiplying fractions, we're going to write it as 9 over 1. So we're multiplying by 9 both sides, but we're writing it as 9 over 1. We have not changed the equation or the proportion at all. Now, on the left, 9 times 2 on the numerator is 18, and 1 times 3 on the denominator is 3. On the right, 9 times y, we don't know what y is, so we just have to leave it there as 9y. When we write a number next to a variable, it means they're multiplied. When we write a number right next to a variable, it means they're multiplied. When we write a number right next to a variable, it means they're multiplied. We don't have to write the multiplication symbol, but you could put a dot if you want. But 9y means 9 times y. On the bottom, 9 times 1 is 9. Now, what have we done? We have now 9 divided by 9, so that goes away. And the only thing we actually have on the right-hand side is y, which is what we want, and then 18 divided by 3 is 6. Flip it around. Y is equal to 6. This is the answer. Y is equal to 6. And if you want to just plug it back into our proportion, originally 2 as compared to 3 was some number y compared to 9, and we have just calculated that we think that the only answer that works here is 6. Is that right? And it is right. What it's basically saying is that 2 as compared to 3 is the same as 6 as compared to 9. And if you think about it, we know that these fractions have to be the same because they're equivalent fractions. If I take this fraction, 2/3, and I multiply it by 3 on the top and 3 on the bottom, I'll get equivalent fraction. If I multiply by 3 and by 3, 2 times 3 is 6 and 3 times 3 is 9. So these have to be equivalent. Because remember, equivalent fractions, I can multiply or divide a fraction by whatever I want, as long as I do it to the top and the bottom. So I'm checking my work by saying, yes, this fraction really is the same as this one, which means this ratio really is the same as this one, because 2 times 3 is 6 and 3 times 3 is 9. So I could go backwards and simplify it. When I simplify 6/9, I'll get 2/3. Either way you want to think about it. All right, we only have 2 more. Let's take a look at problem number 5. Let's say we have the proportion 3/5 as compared to some unknown k over 15. So 3 out of 5 is the same ratio as k out of 15. You might be able to look at that and figure it out. Let's calculate the answer. So let's rewrite. 3 out of 5 is k out of 15. Now, I have the k here. I want it by itself. I'm dividing by 15. To get rid of it, I must multiply by 15. And if I do it to that side, I have to do it to this side. Since we're working with fractions, we're going to write it as 15 over 1 that we're multiplying by. Now on the left, 15 times 3. You might not know that. You might have to go off to the side, but 15 times 3 is 45. And that's very easy for you to multiply out. 15 times 3 is 45. And then 1 times 5 is 5. Over here, 15 times k, I told you, you don't know what k is, so you just have to write it as 15 times k, and you don't have to put a dot there. When you write a number and a letter, you know they're multiplied, and then 15 times 1 is 15. But look what happened. Because we did the proper thing, the 15 will cancel with the 15 because they will divide away. And what I have found is on the right-hand side, all I have left is k, and on the left-hand side, what is 45 divided by 5? It's 9, because 9 times 5 is 45. And then I flip it around, I can say k is equal to 9. So I figured out what k is, and I can rewrite my proportion. 3/5, 3 compared to 5, is some number compared to 15. Right? And we said that the number is 9. So this is the revised proportion here. So the value of k is 9, and the number that we're trying to find was 9 there. Is this correct? What we're saying is the ratio 3/5, or the fraction 3/5, is the same as 9/15. And if you simplify and go backwards, divide by 3, you get 3. Divide by 3, you get 5. So these they are equivalent, they are the same, and so the 9 is the only number that goes there to make that happen. Another way of looking at it is, if you have 3 chocolate candy bars out of 5 total pieces of candy, the different kinds of candy, so 3 out of 5 chocolate bars would be the basic ratio. That's the same as 9 chocolate candy bars out of 15 total pieces of candy. You're still comparing chocolate bars to total types of candy. Here is a simplified ratio, 3 out of 5 as compared to 9 out of 15. The same ratio is the same in both cases. So this proportion there is satisfied. Here's our last problem. Let's finish strong and solve the last one. Let's say that we have 3 as compared to 4, and that's the same as z as compared to 12. Now, when I write my z's, I put a strike through it, and the reason I do is because when you write z a bunch, like if I go down here and write z, 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 you see they start looking like a 2. So when I put a strike through, it just means it's telling you it's not a 2. And that's just something I do. You can write a z however you want to. This is my z. Let's figure out what the value of z has to be. Let's rewrite. 3/4 is z over 12. But that 12 is on the bottom, and the only way to get rid of it is to multiply both sides by 12. So we'll multiply by 12, right? And we'll do it over 1 like this. And then when we get to the next step, 12 times 3 is 36, and 1 times 4 is 4. And then 12 times z, we can't really multiply it, so we just call it 12z, 12 times z, and then this is just 12. But notice I have a 12 on the top and a 12 on the bottom, so they divide away. And the only thing I have left on the right is z. On the left, 36 divided by 4 is 9. So I figured out that z is equal to 9. This is the answer to the problem. Z is equal to 9. Now let's rewrite our proportion. 3 as compared to 4 with some number, z we called it, compared to 12. And the only number that really works there is what we found, 9. Right? Because 3 out of 4 people like chocolate in a room, that's the same as 9 out of 12 people liking chocolate out of a room. You walk into a room and you ask 12 people, how many of you like chocolate? 9 of them say yes. That's the same ratio, the same relationship as if I only asked 4 people if they like chocolate and 3 of them answered yes. So we have conquered the idea of a proportion here. We've also conquered the idea of solving an equation. So it's our first kind of like double whammy. We've learned 2 important things. A proportion is when you have 2 ratios that are equivalent. That means the relationship of what you're studying, even though the numbers are different, the relationship is locked in place. 3 out of 4 people like chocolate, 9 out of 12 people like chocolate, same relationship, and that's why they're equal. So because they're equal, we call it an equation, and we have an unknown, and we're trying to figure out what that unknown is. Now you can guess a lot of times and figure out what these answers are, but by doing it the way I'm showing you to do it, then you're going to be able to, as we go further, solve more and more complicated kinds of problems. So don't skip this. Don't just say, oh, I got it, I'll just guess the answer. That's not the point. The point is to learn the skills of solving these simple equations. We're going to get farther. You're going to learn how to solve many more types of equations than this. So I'd like you to go through from the beginning. If it didn't quite make sense the first time, please watch again and get your pencil out and try to solve these yourself. Every time we're doing the same thing. Multiply by 9 to get this by itself. Multiply by 15 to get this by itself. Multiply by 12 to get this by itself. We're doing the same thing to both sides to get the letter, the variable, by itself. That's how we solve proportions. That's how we solve equations. Solve these yourself. Follow me on to part 4. We'll get a little more practice with solving proportions in math.